Okay, we're doing pretty well with these. Let's just make sure. Okay, let's take this one. 2 times the quantity x plus 3 equals 9. Okay? Now we use the distributive law, 2 times x plus 2 times 3. Right? So that's 2x plus 6 equals 9. Then we subtract 6 from both sides. So we have the x's here, and there's my numbers over here. I think we all know this, but let's just make sure. Now sometimes you want to write a minus 6 here and a minus 6 here and do this. I hate that, but it's okay. Okay? Because you're not showing, I think it's bad form, but that's what everybody's being taught to do, and I can live with it because it works. And it does show you what's going on. Okay, I think it's terrible documentation, but I'm not going to yell about it. Okay, so we have 2x equals 3. We divide both sides by 2, and of course we want to show this step. We don't want to just skip it, okay? Because we want to show that we're applying a rule, okay? And the rule is we can multiply both sides by the same thing, and basically we're multiplying both sides by 1/2, right? Of course, we can divide both sides by the same quantity, and we could divide by 2, that's all right. As long as the quantity isn't 0, you can't divide by 0. I hope everybody in my class knows exactly why you can't do that. Like, how long does it take to get 10 apples if you get 2 apples every day? 5 days. How long does it take to get 10 apples if you don't get any apples any day? You never get them, and never is not a number, it's undefined. Divided by 0. 10 divided by 2 is fine, 10 divided by 0 means nothing. So anyhow, we get x equals 3/2, and I think everybody had that. I just wanted to emphasize that we always want to be conscious of what rule we're following to be sure we're actually following a rule and not some superstition that's wormed its way into our consciousness. And it's real easy for that to happen, okay? You know, you get used to doing things and something looks like something else, you do it by what it looks like, which is what I mean by doing it by superstition, instead of knowing what your rules are and you make a mistake and it's costly, okay? Okay, so now if we have 4x equals 8x minus 12, it's just a little trickier. It's not quite what you want to see. Well, what you have to do is you subtract 8x from both sides, which will have the effect 8x minus 8x is 0. That just leaves you negative 12 on this side. So you get negative 4x equals negative 12. So that you have negative 4x over negative 4 equals negative 12 over negative 4, and that's 3. So x equals 3. Okay? Fair enough? So since you have x's on both sides, you got to be careful, and you got to. Your goal is to have your x's on this side and your numbers on the other side when you're solving a linear equation. Now maybe here we'll distinguish a linear equation from like a quadratic equation, but we'll see how far we get with linear equations. Okay. So the next equation I wrote down was 2 times the quantity 3x plus 4 equals 3 times the quantity 2x minus 6. Okay? So when we multiply out using the distributive law, we get 6x plus 8 equals 6x minus 6. So what are we going to do now? Well, we want the numbers over there. We want the terms with x on them over here, right? Okay, so first thing I'm going to do is I'm going to have 6x plus 8 equals 6x minus 6. And we're going to subtract 6x. I didn't leave myself room to do that. I was careless. But can you see that okay? Subtract 6x from both sides. Well, that gets rid of the 6x over here. We just have negative 6. What do we have over here? Six x plus 8 minus 6x. Let me write that more clearly. Just so you can see it. What's that simplify to?
You did that first step wrong.
I'm sorry?
You did that first step wrong. When you did 3 times -6, you put -6 instead.
When I did 3, oh, you know, yeah, okay. There's an error here. I didn't multiply through, as I say, I can get a little careless sometimes, so watch them. Yeah, that'd be -18, right? Okay. But now, what happens over here? What do you get on the left? That just simplifies to 8, doesn't it? Because you got 6x and a minus 6x, that's 0. And you add that to 8, you get 8. So you get 8 equals -18. Now what can you tell me about the statement that 8 equals -18? Is it true or is it false? It's a false statement. It's a false. So the equation is equivalent to false statement, so there's no value of x makes the statement true. Okay? So there's no solution. Okay? And you want to know all of that because, like, you might have occasion at some point to put an equation into a computer algebra system and ask it to solve the equation. The solution that you get in many systems will just read false. Okay? It won't say no solution. It won't say there's no value of x that makes the equation true. It will just say false, but it means all those things. Okay? If you're writing it on paper, you really want to write out no solution. And then maybe you want to write under that false. And maybe even under that, no value of x makes it true. Okay? Because you want to understand all those things, there's a good chance that that'll be important at some point. Okay, so now let's get to the easy one. Okay, nothing to it, right? Well, actually, there is something to it. It's not familiar. You have an x in the denominator, and you have fractions, and I say it way too often, but fractions don't get taught right in our curriculum. People learn to do them when they're 10 or 11 years old and never see them again because they have a calculator in their hand, which ought to be banned. Okay, end of soapbox. Now, what do you do here? Okay, here's a basic principle. This is so important. I'm going to use some of my precious red chalk. Okay? I don't do this often. Well, maybe sometimes I do it often. Okay, 1/3 plus 2 over x equals 5. Okay. Now maybe reading what I wrote as I wrote it. The equation has denominators. It's much simpler if you don't have denominators. With an equation, you can multiply both sides by a common denominator, and like magic, there are no more denominators. Okay? So what do you think might be a common denominator for this equation? Well, what are the denominators?
3, 5, and X. Are you gonna be times it like?
Okay, well,
with 5 and then?
5 isn't a denominator, it's
Just gonna be solid.
but 3 is and X is. 3 and X are denominators, right? So 3X would be a common denominator, okay? Now, if you don't know about fractions and stuff, maybe I ought to print something out on that, because people generally are really bad with fractions for the reasons I mentioned. Not because they're dumb, you learned it fine when you were 11 years old, and you haven't used it since, due to overuse of calculators. Okay, so common denominator. It's 3X, your denominator is 3 and X. You always get a common denominator if you just multiply all your denominators. Now, it's sometimes more convenient to use your least common denominator. Okay? So I would recommend a least common denominator, but that common denominator we get here is the least common denominator. Okay? And I'm not going to get into least common denominators here. Okay? At least not right now. So common denominator is 3X. So we multiply both sides of this equation by 3X. And multiplying it by the left side, we have to distribute through the addition. We get this, right? You know, on the right side, get this. Okay? Now, since we're probably a little shaky on fractions, I'm going to write this as 3X over 1 times 1/3. Of course, 3X times 5 we know is 15X. Okay? So we have a fraction times a fraction here. Okay? Uh-oh. I had more boards than that. Got some stuff behind here, but it shouldn't be distracting it. I got some washable chalk that isn't. Okay? So we can write this as and I'm writing out everything in gory detail, glorious detail, whatever we call it. When you multiply fractions, you multiply the numerators and you multiply the denominators. Okay? So, that's what I've done. Can everybody see that's what I've done? Familiar with that idea? Yeah. Might have been a little while since you've done it, but that's easy enough. Okay, what's 3X times 1? And what's 1 times 3? It's 3, right? and we get 6x over x equals 15x. Now what do? Well, what people often do is, again, akin to superstition, they use cancellation, which I don't acknowledge as even a valid mathematical operation at this stage. Simply because people never know the rules. I mean, I'm not surprised if somebody cancels this x with this x and this x with this x. Just cross out x's. That's cancellation, right? No, that's not what it is. There are rules for it, and nobody seems to come out of our curriculum to a pre-calculus course knowing those rules very well. Okay? So I don't like to use it. So we're going to rearrange this. And I can multiply, okay, this is also a product of fractions. 3x over 3 is 3 over 3 times x over 1, isn't it? And 6x over x is 6 over 1 times x over x. And our 15x is still sitting over here waiting for something to happen on this side, okay? So now what's 3 over 3? So this is 1 times x, because x over 1 is x. I don't want to do an extra step, change that. That's 1 times x. Of course, 6 over 1 is 6, and x over x is 1. And that's 15x. Well, at this point, you can complete the solution of the problem very easily. Okay? So I'm going to run over to the printer again while you finish this problem, and then I'm going to give you a couple more to work, okay? So let's try. This one. And this one. Try to use steps like the ones I've used. Don't be crossing stuff out like cancellation. Because if you do, I'm going to ask you to give me the complete set of rules for cancellation. Okay? Not to put you on the spot, just to make sure you know the rules and can follow them.